2, 3. Puh! Dr. Knack,
Dr. Bilo.
what do we do today?
Today we're going to see Professor Dr. Jens Schneider, who holds the chair of structural design at the Institute of Structural Mechanics and Design at TU Darmstadt. So he's teaching structural design for civil engineering students. Next to that, he's specialized in glass. He holds a PhD in structural use of glass. He does research in dynamics, bridges and things like this. Runs an energy performance group. Within this energy environment, he developed a very nice concrete cladding facade system. And that's what we're going to see today.
So today is about concrete and concrete facade cladding.
Yes. We may have to wait a bit, because next to all these activities, he's also vice president of this university, so it may take a time till he comes.
No problem, I make a coffee.
Yes, a coffee. Another one.
Immer gut.
Ja. Schnitt.
Schnitt. Drück mal auf Pause.
Da oben.
Ja.
First thing we're going to talk about is concrete as a cladding material. We're going to talk about facades and their function. The second theme we're going to talk about is material properties of concrete. And the third theme we're going to talk about is how do you deal with openings, windows and other aspects to be discussed. All right, let's start. Ja, ich fange jetzt einfach an. Okay, Jens. Concrete cladding for facades. This is a piece of solid concrete. This is a cladding. How does a cladding of concrete work?
Yeah, cladding is something different, of course, especially in this case. This cladding are prefabricated elements that are fabricated in a factory, then transported here to the building site, and then they are fixed as a ventilated system here in this case from the back. What you see here, for example.
These are the fixings.
Yeah, behind here.
Brackets.
This is just for aesthetics that we had these brackets been.
And what's the size, what's the thickness of such a piece?
Yeah, this piece is extremely slender compared to the regular concrete you showed, because here we have a micro reinforcement in this cladding, which means you maybe see here very locally this micro reinforcement here on the outside. It's even stainless steel, because we don't have the protection of the concrete for corrosion, which we typically have when it's far behind the surface. And that's why in the outside centimeter we need this special type of reinforcement.
Reinforcement we talk about in a minute. So the first setup is layout. So we have an outer layer of what, 3-5 centimeter?
Yes, this is a 5 centimeter thick concrete panel.
And then there's a cavity.
There's a cavity ventilated. And then there's concrete foam.
Okay, insulation.
Insulation in this case.
And then there is an inner structure.
And the inner structure is again prefabricated elements, let's say regular reinforced concrete.
And function is typical function of a facade. So we have the outer surface, rain protection, then the insulation and the load-bearing structure.
Yes, I mean it's the outside, and in this case it's also a special thing because we have activated the facade. But that's
what we're going to talk in a minute.
That's a different story.
Material properties, concrete and reinforcement. How does concrete work?
I mean, concrete basically typically only takes compression loads. It doesn't take tension loads. Because it's too brittle to take it, and that's why we need the reinforcement to take the tension within the concrete. And typically you have these rebars.
The metal rebars.
The red rebars, of course, in this case they're extremely small. Yeah, that's why it's micro reinforced. But typically you have the normal reinforcement, which is several millimeter thick bars.
In concrete cladding, we also know glass fiber reinforcement for cladding surfaces.
Yes.
Same system?
It's a similar system. The only difference is that the span here, if you see this fixation and the next fixation up there, is very large. And with a fiber reinforcement, you couldn't do such large distance between the supports. And it typically takes less load if it's only fiber reinforced.
But then, say, the size of this 5 centimeter decreases to 2 centimeter or 1.
Yeah, on the fiber reinforced cladding you can have 1-2 centimeter, but then you need maybe only small panels like 1 by 1 meter or something like this, and not such large panels like we have here, 10 meter large.
This is a straight component. It's quite linear. Could you imagine doing this somehow free form to shape it?
Yes, of course. I mean, concrete can be put in any type of form, but you need a form.
So you need the mold?
You need a mold to do it, and the mold is the biggest cost in the mold in the end. Yeah, but any type of 3D form is possible.
Is in general possible. Okay, let's talk about the last part, openings. This is now a typical ventilated facade, so it's entirely closed. We do see that there's an opening in here. It can ventilate in this environment. When we need a window, we just cut it here and place a window.
Yes, if we need a window, then of course, because these elements are prefabricated, then you have the space in the form already, opening, and then you later put the window like we have it in other situations.
When we look at that place, this is where the windows...
Exactly, it's included. You see it has an extra frame around, and we need of course to close the cavity then to the cavity behind here. And this is a typical way to do it. Yeah.
Okay, and then there's, say, metal cladding, and then the window itself, aluminium, whatever material is positioned.
Yes, you mean this is the outside layer as a facade, and then of course we have the structure inside, and also the structure needs to have the opening so that you have the, you have the window.
Clear.
Yeah.
Clear. Shall we go inside to look at the mock-up of this special facade?
Yes, we can have a section view.
That's a good one. Okay, let's go. Okay, so Jens, the first concept was talking about concrete as a cladding material. Okay, we talked about that. We have the cladding, the ventilated, and then the insulation and the inner core. But this is a very special facade, as you said. So what's special, starting with the concrete?
Yeah, like I tried to explain outside, this concrete has this micro-reinforcement. We see it here now in the section. The many little dots are the reinforcement, like you see here, micro mats that are put to make the whole system very durable and also have a large bending capacity. So we only need to fix it 6 points outside. We saw that. And
but it looks like stainless steel.
Yes, the outside, in the outer layer, like I said, because we need on the outer layer we need this corrosion protection.
And that's done by the stainless steel.
Exactly.
Okay.
Then it's special about it that we have the blue things here in between, and these are these capillary mats. They can be used to transport water through the facade, which means, for example, in summer, in the nighttime, you can take the hot water which is collected here inside and then have a free convection outside, and the facade helps to cool the building. And the other thing is in winter, we have the same elements here inside, in the walls. So it's kind of a wall heating. We can use water as a transport medium for energy, which is very efficient because water has a high capacity.
So it's not only for collecting energy, it's also for distributing energy.
Yes, exactly. So we can use, of course, also the other way around. We could collect the water, the heat outside in the summertime, use the hot water, store it somewhere, and use it later, which is also done. But in a factory surrounding, the cooling is the more problematic thing in the end.
In our climate situation. Yeah. Okay, this is outside concrete, and as we learned, it's quite a solid material. And then you talked about concrete form. What's that?
Yeah, that's a new development. You see, so we have the outside cladding, and then we have this ventilated cavity. And then we have this concrete, which is a foam material. It's made from concrete, but it's foamed.
So it's super light.
It's super light. It has a density of about 150 to 200 kilogram per cubic meter. And this is then more than 10 times more. So that's 2,500 kilogram per cubic meter, which is more than 10 times.
Okay, and this insulates. So
this insulates because of the little cavities here within this foam. That is the insulation, like compared to...
Consequence is also clear. I easily can destroy it.
Yes,
so we easily break pieces.
It's very sensible. So we need Also fixation here, there's little steel elements like needles.
I see. For the inner structure, for the concrete form, it needs to be fixed to the inner structure.
Exactly, yeah, because it's so sensible that you can easily destroy it.
You peel it off. Okay.
But you can at least downcycle it, and it's not organic material, and it doesn't burn.
That's true. That's true. Okay. Thanks.
Thank you. Bye-bye.